should be a really quick recap of what we already know fairly well. And if you've had a chance to pull up this worksheet or you've been able to print it out, that's great. If not, that's fine too. Okay, so we just want to recap a couple terms that we need to know before we start the unit. So a variable is anything that data, PS4 gaming right now. Okay, so it could be in the term of a term like that, for example. All right, so what is a term? So a variable is a letter that represents one or more numbers. A term is has a coefficient and a variable usually with it. So you might have something like 3x, or you could just have a number like a constant, or you could have a letter. So those are all different terms or expressions of a term. A coefficient is the number in front of a variable. For example, like this, your coefficient, would be the number in front, not the letter. Okay. What is a constant? Well, the constant could be a number that's not tied to a variable. That's part of the expression. For example, so a constant, this is a constant because it has no variable. And this part of the expression is a constant. All right, so we want to look at like terms. So you remember how to hopefully collect like terms. Okay. Are these like terms or unlike terms? Well, if they have the same variable and the same exponent, they are like terms. This next one has a y and no y, so unlike terms. This has an x and an x, so you're thinking those are like terms. However, one does not have a variable and that one does have a variable, so they are unlike terms. And finally, we have a y and a y term. We're not even looking at the coefficients, by the way. We're only looking at what the variable expression is. So it must have the same letter and the same exponent. So yes, those are the same. Okay, what do terms in a polynomial? Terms in a polynomial can only be added and subtracted if they're like terms. So you can't add or subtract unlike terms. Next. How do we add and subtract coefficients? We want to leave the variables the same, okay? So I think of variables as like a package. So in grade 9, you might have even talked about algebra tiles and said like, okay, well, we have squared tiles, we have single x tiles, and we had just small number tiles. And so that kind of reminds us that these don't look the same. They're not packaged the same. This is an x squared tile. This is a single x tile. So anyway, so we look for like terms. And what I like to do is instead of using tiles by grade 10 or even by the midway or end of grade 9, we stop using tiles and I use an underline system. So I have a single line for like terms and a double lines for a different term. So these are like terms. These are like terms. These are like terms. You find the P's and then maybe do a double underline for different terms. So how do we simplify? So simplify just means gather like terms. Gather your like terms. So 2 plus 5 is 7x. So notice it didn't become x squared. It's just a single x. And so you're really just adding up the subtraction, adding up the coefficients. The biggest thing is to treat your coefficients like any other integers. So 3 minus 7 is more negative. So we're going to left with a negative 7y squared. Okay, we want to add our p's first. So 8 minus 4 is 4p. And negative 1 plus 3 is a difference of plus 2. Any questions on that? If you have a question on the chat, we can take those up. All good. Well, this makes sense. It should be sort of review. Okay, so notice what happens here in distributive law. Maybe we have our first step would result in this, and a second step would be to multiply in this. So we're indicating multiplication here. So Michael, you're asking when our next test is? Now, do you see the screen again? It won't be until this unit is finished. I think this unit has 4 lessons, and we're now spreading out our lessons every second day. So we'll do Monday, Wednesday, Friday, and it gives you Tuesday, Wednesday, and the weekends to practice things. I'll still sign on Tuesdays and Thursdays at the same time if people have specific questions. So, all right. So let's distribute these. So what would be my guess is, well, we have 4 lessons and maybe a review there. So you're looking at 6, sort of 5 days. So you can easily say double that because we're going to go every second day. So we're looking at 2 weeks, maybe giving it to you next Friday. No, not even. So probably after the following weekend. So let's not worry about that too much. We're going to just go. Now, I might have some quizzes. I'd like to send you some quizzes and have those as practice that you get to do. All right. 3 times x is 3x, and 3 times 2 is 6. And there's nothing to do further than that. So we're finished. So some people might go, oh, well, that's now 9x. No, you don't want to do that. That's a big mistake. So don't feel like you can combine those. These are different terms. They're unlike terms. All right. Next. Negative 2 times y is negative 2y. And then you have negative times a negative will turn to positive. And 2 times 1 is 2. So it's important that you take care of the signs, that you make sure you don't mess up your signs. Okay. Next, so here we have 2 of them. We're just going to do one at a time. So when it says, usually this says, sometimes it says expand in the instructions and simplify. These instructions just say simplify, but we really can't until we expand. So expand means do distribution and then gather like terms. That's really the translation. So 3 times x is 3x. 3 times 1 is 3. Then we have our second bracket. Well, a negative times a positive is a negative, and 2 times 2 is 4, and the x continues with it. And then negative times a positive is negative. 2 times 3 is 6. Notice that there's no x on that last term, right? There was no x involved. All right, fine. Then we go ahead and we have 3 minus 4. So 3 minus 4 is negative 1x. And 3 minus 6 is negative 3. And that's where we finish. They're unlike terms, so we don't go any further than that. Are there any questions for that one? Looks okay. That was just sort of that's more of a review, kind of like a getting ready section for going ahead with 4.1. So because it's such review, I thought we'd do both today and go through them relatively quickly, I hope. So we'll pull that one up now. Do you see a new screen getting ready? That's what I did was I loaded myself into the on my phone so I could see, so I don't have to ask you guys that all the time. I just have to get used to doing this stuff. It's a bit of a learning curve. So yeah, that's good. I can see what you guys are seeing. That makes a lot of sense. Okay, so what we're doing is 4.1 solve one and two step equations. You probably have done a lot of these in the past. Okay. So again, this kind of recaps yesterday, or I mean what we just did now. Terms are, an expression is the adding or subtracting of uh, one or more terms. So this is an expression. But when it changes to an equation is now we have an equal sign. Okay, so the thing that changes with an equation is we must have an equal sign. And then so that's the difference between expressions and equations. To solve the equation, it means to find the answer for the variable that would make it equal on both sides. So get the variable all alone on one side, and then you solve for it. Sometimes you can eyeball it and say, okay, well, what would this have to be to make this thing right? So you'd have to think in your head. So that tends to be a little difficult. So instead, what we do is we do opposite operations or inverse operations. Okay, when moving terms across the equal sign, we use the opposite operation. So when we move it across the equal sign, an addition becomes a subtraction, a multiplication becomes a division. We must use our rules of BEDMAS, so brackets, exponents, division, multiplication, addition, and subtraction, but we use them backwards. So you might think of it as whenever you're doing these worksheets, you might write out Sam Deb just to have on your sheet as you're working through, just have that go, okay, I must do these ones first, then these ones, and then exponents and brackets first. So what do I mean by solving these? So you ask yourself, what is happening to the x? The x sort of has, what's happening to the x is it's being added by 2. So the inverse operation is to subtract by 2. So what we do is we subtract. Now, here's the real way to write it out, and I'll show you different ways to do this, just using different colors. Obviously, you might not use different colors every time you do this, but here we put the -2 in and the -2. So you're jamming this into these problems. So Emma, you don't have that page. So it would have been something that we emailed out to everyone. It would have been 4.1. So we'll share the video afterwards, so you can kind of dig up that file later, maybe. Okay, well, I guess it's possible it didn't end up in the email package. Can't tell right now what it would have been, but often when you're doing that many things, it might be tough to. It's easy to miss one file. Well, let's continue, okay? And if you want, you can always write the next question out on a piece of paper and then try it. But we want to stay within our time frame here of our meeting. Okay, so what happens is these eliminate, obviously, 2 minus 2. So we are going to have, you don't have that one either? Okay. Well, this is the joy of online teaching, is the difficulty is sometimes people don't get. So I'll share it out again, okay, guys, but not right now. So I'll have to do it another time. So what we end up doing is getting reduced to the x alone and 5 minus 2. So 3 is here. Okay, so what's happening in this case? Well, our operation is -3, so we are going to have to add 3. So another way I like to show it, so I'm kind of just showing you different ways to do this. Some people if you watch a Khan Academy video, which I really recommend if you're ever stuck, you're not sure how to, you need some tutoring or something, the Khan Academy website, so khanacademy.org is really good. Anyway, they always show this by doing like a vertical addition. So the m would have nothing to add to, so the m would continue. -3 plus 3 would cancel itself out. Khan Academy and chill, yes. I'm sure that would be, they'd love that promotion. 7 plus 3 is, or 4 plus 3 is 7. Okay, so that works too. We eliminated one side and then we had the equivalent side, so m would be 7. All right, here we finally see a different, what is the main operation happening here? Well, it's multiplying by 4. So we are going to divide by 4. So divide both sides by 4. And so whenever we divide that, that's going to make cancel and cancel to ones. Well, of course, 1 over 1 is just 1. So we have a equals, and then we say, okay, well, 4 goes into 4 one time, and 4 goes into 24 6 times. So our answer is a equals 6. All right. They get more complicated after that. Those ones are pretty easy. Oh, it says to check. So what I'll do is I'll show you one check, and then, so how would you check that? So you can do left side, right side. And so on this side, we had x plus 2 and 5. So if we substituted our answer in for the x, what will we get? So 3 plus 2 is 5. So left side equals right side. So therefore, we're correct. And we could do this for each one. You could also just do it like this, write it like this, a check, and say m minus 3 equals 4. And then you'd say 7 minus 3 equals 4, and you'd keep the left side and right side separate. You say 4 equals 4 is correct. So that's a way to do that. So 4 times 6 equals 24. So left side equals right side, and I must be correct. All right. Good. Any questions on that one? Any problems? Again, those are one-step problems, so you're probably pretty familiar with them from grade 9. Maybe even touched on them in grade 8 and probably grade 8 and maybe 7. So they can get a little more tricky where we now have like a two-step problem here. Actually, this is still a one-step. Here we have a two-step. So one step, two-step. So, you guys still see my screen with the lesson? So I was trying to watch. Oh, there we go. Okay. Like I said, I'm trying to follow along on my phone so I see what you guys see. Okay. Again, we're all learning more and more about this online teaching and how to use the tools, right? So we want to say, okay, well, we're dividing by 5, so the inverse of that, when I say inverse, I'm going the opposite direction. Like here's our operation going this way, and I'm going to do the opposite. So how would I write that? So I would say 5 bracket n over 5 equals 5 times the 3. Now, the whole reason we did that was so we could cancel these out. And that becomes 1 and 1, which is 1. And so we're left with now a 1n, But of course, we wouldn't have to write the 1. It's just for teaching purposes. It might help to see it there. So n equals 15. Okay. Next, here we have a 2-step problem. So I like to look at these as like having layers. Always think what's the closest thing happening to the x? What's the next closest thing happening to the x? And so do that first. So I have it's being multiplied by 2 and then added by 1. So my inverse operations are, first I want to subtract 1 and then divide by 2. So let's do that in those steps. All right, so 2x plus 1 equals 7. And we can put in those minus 1s right there. So we have 2x, and these cancel each other. So 7 minus 1 is 6. All right, so we sort of did this step now. So that step's done. And our next step is to divide both sides by 2. So you can either start it right there, or you could start right again and say, okay, I'm going to divide both sides by 2. And I certainly don't expect you to have color-coded pencils to do all this, but I think it helps with the presenting it. All right, so the 2's cancel out. That's the whole reason why we did it. X equals, well, how many times does 2 go into 3? 6, 3 times. So that's good. Sometimes in final answer, you might have been trained to box those out. Kind of tells the teacher, like, okay, I've finally reached the end. I'm happy. My answer. Next. So we have what is happening to the x first. So the first thing happening, the first layer is we're being multiplied by 3. The second layer is being subtracted by 17. And in grade 9, I go on this whole thing. It's like onions. Onions have layers. The closest layer you want to deal with first, the furthest layer. And so when we or we're like tangling up, we're raveling up a problem, and then to unravel it, we start with the outside first. So if we start with outside first, we're going to have to add 17 and then divide by 3. So 3x minus 17. I'll show it the other way because the more and more I do this, I like this way. I'm going vertical. I find it helpful. But because I find then I have to rethink how I jam these in over here. And if I don't make space for it, it looks kind of weird. So anyways, those will cancel out. And we have 3x equals, okay, so 28 plus 17, what are we looking at here? We're looking at 45. That's good. And we know 45 is a factor of 3, or 3 is a factor of 45. So we're going to divide both sides by 3. And of course, 3 goes into 45 15 times. Just a coincidence that the answer to D was 15, but you box that answer so that you're communicating to your teacher that it's finished. Any questions at this point? All right, so we're still dealing with 2-step problems, and as they go along. So maybe I'll give you a moment to try posting your answer if you can figure out that. So if we're all working on G right now, I'll give you 2 minutes. See if you can figure out these 2 or these 3 on your own. Maybe we can get a different person answering each one. All right, so we'll make it a bit of a race. Who can post the answer to G? Let's see if you get it right. So we have an answer of -4. Liam, that's great. All right. So I'll write it down. And as I'm doing that, if you want to try H, and Liam's going to hold off answering it and give someone else a chance to post H. All right. So again, the first thing I want to do is get that 4 away. So again, it helps me to list the functions and the operations, sorry, and then I want to do the opposite. So the first thing I want to do is subtract by 4. Subtract 4 on both sides. So I'm left with a 0. You could write the 0 in, by the way. I didn't mention that before, but it's almost pointless. So 16 minus 4 is 12. And so then we divide both sides by -3. And then that cancels into a +1. And then we have negative, so 12 divided by 3 is -4. So good, great job, Liam. Maybe someone else. So what about H? H looks a little more complicated, but might not be when you get down to it. Start off by listing your operations. So the first thing happening to the K is being multiplied by 3. The second thing happening to the variable is it's being divided by 4. So we want to do the inverse operations, and yeah, Jacob, you got it. It was -4, and then Liam jumped ahead and already answered that question, even though I asked him to give someone else a chance. All right. So we're going to start off by multiplying both sides by 4. So I would contain everything in a big bracket, and then the single variable in there. And the whole point again was to eliminate the top and bottom. Because this is a numerator and this is a denominator, they're going to cancel. Now you could multiply that in and become 12, but as soon as you go 12 divided by 4, you're going to come up with a 3 anyways. So it's kind of pointless. So it's better to just do it that way. I'll show that just in case, because some of you might be wondering, well, why don't we do that? And how does this all work? And why do we keep it outside the bracket? So let's say I did that. And on this side, we get 36, so 4 times 9. So if you had done that, this distribution like we've just been learning from the last time, we would say, okay, 4 goes into 4 and 4 goes into 12 3 times. Well, lo and behold, we're right back to where having 3K. So I guess it's a time saver if you just leave it and you do the canceling before. Always try to reduce before. Reduce as early as you can, anytime you can. All right, so we're left with 3's. Now, the opposite of dividing by 3, of multiplying by 3 would be dividing by 3. And so we have K, that's going to cancel. K equals 12. So very good again, Liam. That was a great job. And our last one, if you want to try and race, Liam, let someone else do it. Who's still in our room? Emma's there, Jacob's there. Michael, you probably. Oh, Liam, maybe Liam's not. Oh, I don't know if the other one's gone. I can't see everything on the screen all the time, so I only know what I see. Okay, so the only thing really happening to this is being divided by -2. So our inverse operation is to multiply by -2. And so we have -2 times n over -2 equals -2 times 4. And so, cancel those out. Oh, it doesn't. It should have a different color. And so we have m equals -8, as you guys showed in the chat group. So one and two step equations. It's a good reminder of key skills that we need as we go forward in the course, because from this point on, we are always rearranging equations. We're always trying to solve for the variable. So it just keeps, these skills are important as we solve equations.